Assalamualaikum warahmatullahi wabarakatuh and good evening. So in previous lesson, we have already learned about material balances on multiple unit processes with recycle. So today we are going to continue on the material balances on multiple unit processes with bypass. Okay. Right, so let's move on to the next slide. So here we have learned about recycle. Now we are learning about bypass. Let's recap back what we have learned about recycle. So we have a process flow here at the bottom on the right. So we have A plus B, where in the process, A plus B will form C. So we are expecting that for the outlet, for the output, we're going to have A, B, and C. So for a recycle system, why we recycle? We want to recover or reuse the unreacted material, which is in this case is A and B. Because of that, after the process, we need a splitter. So the splitter is positioned after the process. We split some of the stream will be recycled back into the feed. So here we have the feed. So the feed will be mixed with some of the recycle, mix and enter back the process. So this is recycle. So what's the difference with bypass? So let's see the bypass flow chart. So here we have the bypass flow chart. We have a feed. So instead of having a splitter after the process, we are having the splitter before the process. So we have a feed here, then we have a splitter. So we have a splitter, some of the stream will go into the process and some of them will be bypassed, passed from the process and go to be mixed with the output of the process. Here we have the output and here we have a mixer. So it's a contrast to the recycle. Recycle, we have a mixer first. After the feed, we have feed, mixer, process, splitter, and then the final output. For the bypass, we have the feed here, we have the bypass, we have the process, and we have a mixer here. And then finally, we have the output. So remember back for a splitter, remember back the story, we have an orange juice in a jar. We want to distribute among you. One of you have a cup, some of you have a glass, some of you have a bowl. So the taste of the orange juice must be exactly the same. So the molar composition or mass composition should be exact for the feed and also in the bypass and the inlet stream. The one that will be different is the mixer. So what is bypass? Bypass basically a fraction of the feed. So we have a feed here. So a fraction of the feed is diverted around the process unit and combined with the output stream. That's basically bypass. Why we are doing bypass? Because we want to control properties and composition of the product stream. There are some reason we want to control. We want it to be in a certain composition. That's why we bypass. We mix it after the process. Okay, now let's see example 4. Okay. Take 1 minute, pause the video, try to understand the question. Okay, let's say you have understood the question. Okay, but before that, don't forget to comment in case you have any inquiries during the process. Okay, let's see the example 4. Back to the question. In textile industry, it is desired to make caustic soda solution containing 24% NaOH, sodium hydroxide, by mass, for a mercerization process. So what do we want to produce? We want to produce 24% NaOH. Okay, not mole percent, weight percent. Due to the very high heat of dissolution of caustic soda in water, this solution is prepared as follows. What are the steps involved? First, in a dissolution tank. So we must have a dissolution tank, the first unit. In a dissolution tank, caustic soda of 50 weight percent NaOH was prepared. So 50 weight percent of sodium hydroxide was prepared from a dissolution tank. Is it a feed? Is it a product? It was prepared, so it must be product. By mixing, 100 kilogram of solid sodium hydroxide. So how do we produce 58% sodium hydroxide? We mix 100 kilogram of solid sodium hydroxide with water. So we are expecting there should be a few streams. One stream would be a solid stream of 100 kilogram of sodium hydroxide. Another stream will be water. So there should be two streams lah. It was then fed to the dilution tank. What was fed to the dilution tank? Right? Think, what was fed to the dilution tank? What we are talking about? We are talking about the 50 weight percent sodium hydroxide. So this 50 weight percent sodium hydroxide was then fed to the dilution tank. First we have dissolution tank, then we have another unit, dilution tank. So this is our second unit, where a fraction of feed water is added to produce the desired solution. Okay, what the question want? First, calculate the amount of water required. How much water is required? B, calculate the amount of desired solution produced. How much we produce? Yeah, we want 24 weight percent NaOH by mass, but how much amount is it produced? C, calculate the amount of 50 weight percent sodium hydroxide solution produced. We know the composition, but how much? How much is the amount? Calculate the amount of feed water that is bypassed to the dilution tank. Now we need to know the feed water that bypassed the dilution tank. So we got a hint here. Where is the bypass positioned? E, calculate the ratio of water that is bypassed to the dilution tank to that is fed to the process. Okay. Take a step back. Okay, take 1 minute or more to draw based on the question. If you are ready, then you can continue the video. Okay, now we have to draw a process flowchart based on the question. Okay, let's see our process flowchart. Let's compare back with our question. We have to produce 24 weight percent sodium hydroxide, so it should be positioned as the output of the total process. So we have here 24 weight percent sodium hydroxide. Do we know how much is the amount? No, we don't. So it's written as S2 kilogram. Why is it kilogram? Why is it not kilogram per hour? Why is it not in a form of flow rate? Because we got a hint actually. Remember back the question, we got a hint. But among the information given, there is one amount given, which is 100 kilogram of solid sodium hydroxide. It is not in the form of flow rate. It's in a form of mass. So that's why the others should be in the form of mass as well. And this amount given from the question will be our basis. So this is our basis, which is 100 kilogram of solid sodium hydroxide, which entered the dissolution tank, because this one is used to prepare the 50% NaOH. Okay, and then what did it say? Okay, it mentioned about this step. Remember back, we have two units. First is the dissolution tank unit. Second is the dilution tank unit. Okay, for the dissolution tank unit, the question said that it was used to prepare 50 weight percent NaOH. Thus, it should be a product from the dissolution tank. How it was prepared? It was prepared by mixing water here and also NaOH, solid NaOH, around 100 kilograms. So we have two input, water and also 100 kilograms solid sodium hydroxide. But we don't know the amount of water. We also don't know the amount of 50 weight percent sodium hydroxide produced. Okay. And then another information, it was then fed. So this 50 weight percent NaOH was fed to the dilution tank. So we have a dilution tank here, where a fraction of feed water, we have a feed water here. Feed should be the first stream. So feed water here, a fraction of it is added to produce the desired solution. Where it was added into the dilution tank. So here there should be a splitter from the feed water, split to bypass the process, go to the dilution tank, because a fraction of the feed water is added into the dilution tank. Okay, now we have a complete process flowchart. We also have several unknown. What are our unknown? We don't know how much is our feed, the water, W, in form of kilogram. We also don't know how much fraction of it was bypassed. We don't know W2. We don't know how much was fed into the dissolution tank. W1, we also don't know. We know how much the amount of solid NaOH, which is 100 kilograms. We don't know the produced 50 weight percent NaOH, S1. We don't know also in the end how much we get our target, which is 24 weight percent NaOH. What are the rest in here? That would be our other component, which is water. So 50 weight percent NaOH, 50 weight percent water. 20 weight percent NaOH, around 76 weight percent water. Okay, now what do? We have the process flow chart. We have to select boundaries and perform degree of freedom. When we perform degree of freedom, then only we know from where should we solve the problem. Okay, let's say we start with the overall process. So if this is the overall process, we have covered all, including the bypass. Then we have one input, two input. One is the water, the fresh feed water. And then we also have the 100 kilogram solid NaOH. So we have two input and we have one output, which is our targeted product, 24 weight percent NaOH. But we have unknown as well. So when we perform degree of freedom, our unknown are W, kilogram of water, and also S2, kilogram of 24 weight percent NaOH. How many independent material balance we can write? Since we have two components here, one is water, one is NaOH, we are able to write two equations. So 2 minus 2 is equals to 0. So we are able to solve the question from the overall balance. We perform the overall balance. Let's say we start with the NaOH balance. So here we doesn't have NaOH in the water stream. We only have NaOH in the solid NaOH and also in the product. So input is equals to output. So our input is 100 times 1. Our fraction, since it's pure, so it will be 1. Equals to our output. Here we have 0.24 times S2. So from the NaOH balance, we should be able to solve for S2. Then we have total mass balance. So total mass balance will simply be W plus 100 to get S2. S2 we solved already. We are able to solve W. Now we get S2 is 416.7 kilogram. W is 316.7 kilogram. So we have solved for S2. We have solved for W. Now we are going to look into the process unit. Okay, so which process unit should we start from? We have two process unit plus one more, which is a splitter. But which one we should start first? Okay, let's see dilution tank. Let's see the degree of freedom analysis. Now we have dilution tank here. What are our unknown? We have S1, W2, and S2. But S2 we already solved during previous equation. So we only left with two unknown, which is W2 and S1. And then how many independent balance? Since we have two materials, water and NaOH, there's two independent balance. So 2 minus 2 is equals to 0. We can continue with dilution tank equation. Okay. Solve it. Start with NaOH balance. We have NaOH here. We have NaOH here. Input is equals to output. 0.5 times S1 equals to 0.24 times S2. We know S2 is 416.7. We are able to solve for S1. Then we do the total balance. S1 plus W2 is equals to S2. We know S1, we know S2, we can find W2. So now we know S1 is equals to 200, W2 is equals to 216. So we have solved this part. We also have solved this part. Okay, thus we can actually solve for the dissolution tank. So dissolution tank, if we do the balance, W1 is simply W1 plus 100 equals to S1. We know S1, we also know the 100, so we can solve for W1. We got W1 as 100 kilogram. So we know W1, we know W2, so the question asks for the fraction, how much fraction of the water is bypassed to go to the dilution tank. That will be W2. That is the amount of water that was bypassed over the feed, which is W. That is 0.684. W we already solved during the overall balance. So now we have solved the question. You can take some of your time, try to read back and understand the solution. Okay, if you understand this, go to the second example, example 5. So here we have, okay, pause for a while and try to read and understand the question by yourself, and try to ask yourself to draw and label the flowchart of this process before we continue. Okay, now let's proceed. If you have any question, just simply comment there and we will discuss it. Okay. All right, now let's see the question. Fresh orange juice contains 12 weight percent solids and the balance water. And the concentrated orange juice contains 42 weight percent solids. So we have two streams here. One is the French orange juice. Okay, fresh orange juice contains 12 weight percent solids. Balance water. How much is water? That will be around 88 weight percent water. Okay, and then the concentrated orange juice, so we have another stream. The concentrated orange juice contains 42 weight percent solid. What are the rest? The rest will be water. So it's just concentrated. So here is 42 weight percent solid. How much water? That will be 58 weight percent water. Initially, a single evaporation process was used for the concentrated. Okay, but volatile constituents of the juice escape with water, leaving the concentrate with a flat taste. So this was a problem and we will not proceed with this problem. I mean, we will not use the same procedure. The current process, now what are the process that we are using? So this is our current process. The current process overcomes this problem by bypassing the evaporator with a fraction of the fresh juice. Now what we have done, we have created a bypass. Okay, the juice that enters the evaporator is concentrated to 58 weight percent solid. What are the rest? The rest will be water. How much water? That will be 42 weight percent. And the evaporator product stream is mixed with the bypass fresh juice to achieve the desired final concentration. So we have our desired final concentration. We have a fresh orange juice. This is our target, 42.8%, but in the middle, we will get 58%, and then we will create a bypass. Now we have to draw and label a flowchart of this process. Then we have to perform the degree of freedom analysis and calculate the amount of product produced per 100 kilogram fresh juice fed to the process and the fraction of the feed that bypasses the evaporator. Now, the question, if you read back, it only mentioned composition. It did not mention the amount at all. So what will be our basis? We have to set our basis. Okay? All right. Try to check your flowchart and let's compare with ourselves. Okay. Here is our flowchart. Compare yours with this. Is it right or wrong? Okay, now we have an evaporator. We have a mixing point. We have a bypass. How did we end up with this? Now let's check back the story. We have fresh orange juice contain 12%, 12% solid. So this is our fresh orange juice here. Is a feed, is the fresh one. Why suddenly we write basis 100 kilogram here? We have a choice whether we want to put 1 kilogram, 1000 kilogram. But why do we put 100 kilogram? To ease us for the second question. Is it mentioned about 100 kilogram fresh juice fed to the process? So why not we just simply use that as a basis? So we put 100 kilogram as the basis directly. Okay, so this is our what we have, our starting material. And then we have our target where we want to produce concentrated orange juice containing 42.8% solid. So that will be our final output. Here we see 0.42 kilogram solid per kilogram. That will be our output. The rest is water. Okay, then we actually, before this, what do we do? How do we produce this concentrated orange juice? Simply, we use an evaporator. That was before this. Initially, a single evaporation process was used. Before this, we only have an evaporator. But we have problem. Volatile constituents of the juice escape with the water, leaving the concentrate with a flat taste. So that was a problem. Now, what did we do? We bypass the evaporator with a fraction of the orange juice. We bypass the evaporator with a fraction of the fresh orange juice. This is our fresh orange juice. We bypass, before we enter the evaporator, we bypass some. So this is our splitter. We bypass some. Directly we mix with the output. That is what it meant. Bypass the evaporator with a fraction of the fresh juice. Some of the fresh juice is put into the evaporator. Some is bypassed and go directly mixed with the output. Okay, the juice that enters the evaporator is concentrated to 58% solid. So we actually put the orange juice. This is the fresh. We bypass some, so some enter here, and we concentrate it into 58% of solid. So here will be the output. Why here? Why not here? Okay, let's say you got confused. Why 58% is actually the product? First reason is, of course, the statement itself lah. The juice that enters the evaporator is concentrated, so there is an action there. Let's say you got confused, you don't understand the question. So remember back that we have a splitter here. Bypass is a splitter. So splitter, remember back the fresh orange juice that I mentioned to you, the example. We have a jug. Everyone have different type of, cup or glass or bowl, different size. So what's the same thing? The same thing is the taste of the orange juice. That would mean the composition is the same. So the fresh water is 0.12 kilogram solid per kilogram. So the one enter the evaporator must be the same. The amount that fraction that bypass also must be the same. So here the composition is the same with this one and also this stream, the bypass stream. So what's left? The 58% solid, that must be the output of the evaporator. So this is the tip in case you got lost with the question. Okay. And remember back, evaporator, the function is to evaporate some of the liquid. So that's why we must have another stream, which is here. We have the one evaporated, which is water, pure water. We don't see solid evaporate suddenly. Okay, so it must be a pure water here. But do we know the amount? No. The only amount that we know is our basis, which is the 100 kilogram of fresh orange juice. So it was given in form of mass, not flow rate. So everything should be in the form of mass. So we have kilogram here. The composition is in a mass composition. So we have completed the composition. We have no issue on the composition. Here, what will be the composition? It is pure water. So 1 kilogram water per kilogram lah. So only the amount we don't know except the amount of the fresh feed. Okay, now we settle with the labeling of flowchart. Now, how about the DOF, degree of freedom? In order for us to solve this question, we need to solve by starting with the DOF. Okay. Let's start with comparing the DOF for everything. We start with the overall. This is our overall. So if this is our overall, how many input we have? We have only the fresh juice. One input. How many output? We have M3 and also M5 string. We have 2 output. So what are our unknown? So we have M3 and M5 as our unknown. How many balance do we have? That will reflect by the number of materials. So we have solid and also water. We have 2 materials. So 2 minus 2, we have 0. So we are supposed to solve it starting from the overall. But let's see the DOF for the other unit. We go to the evaporator. So evaporator, what are our unknown? Let's see what are our input and output. So we have one input, which is M1. We have 2 output, which are M3 and also M4. So how many unknown we have? M1, M3, 4. That's 3 unknowns. How many balances? There are only 2 materials. There's 2 independent balance. So 3 minus 2 is equals to 1 degree of freedom. Cannot be solved yet. Then we see our bypass. So bypass, how many input? 1 input, 2 output. Our input is here, our output is here, M1 and M2. We know our input 100 kilograms, so our output only we don't know. So our unknown is M1 and M2. 2 unknown. How many independent balance? Okay, remember back. Similarly like recycle, we have a splitter here. For a splitter condition, even though we have 2 materials, suppose if you have 2 materials, that would mean that you have 2 independent balance. So that is an exception for a splitter. So we have splitter in bypass, we have a splitter in recycle. So if we have a splitter, even though we have 2 materials, we actually only have 1 independent balance. So 2 minus 1 is 1 degree of freedom. We cannot solve from the bypass. Okay. Lastly is our mixing point. So mixing point, we have 2 input, M4 and also M2. We have 1 output, which is M5. So we have 3 unknown, M2, M4, M5. How many balances? So we have 2 balances because we have 2 materials. So 3 minus 2, 1 degree of freedom. So basically, how do we solve it? We can start from the overall process. If we solve the overall process, we are actually solving M3 and M5. Then where should we continue? We can see the degree of freedom. So all other unit has 1 degree of freedom only. So if we know one of the unknown, then we can solve it. So you can choose actually, since you have solved M3 and M5, you can start either from evaporator or mixing point, because knowing M3 and M5, you have reduced the unknown in the evaporator, which is connected with M3. You also have reduced the unknown for mixing point, which is connected with M5. So you can continue with evaporator or mixing point, then only you continue with the bypass. Okay, then we solve it. We start with the overall balance, since overall balance is the DOF is 0. So overall balance, we start with the solid balance. So overall here, so we have 0.12 times 100 is equals to 0.42 times 5. Okay, so M3 doesn't have solid at all. So input is equals to output. We can solve for M5. And then our overall mass balance, 100 is equals to M3 plus M5. We solved the M5 just now. We can solve for M3. Okay, done M5, done M3. Now we go to the mixing point, because we solved already for M5. We go to the mixing point, mass balance, M4 plus M2 is equals to M5, which we know. The M5 we know actually. So we know M5. So we can solve this one lah, M4 plus M2 equals to M5. Mixing point S balance, solid balance. So solid 0.58 times M4 plus 0.12 times M2 is equals to 0.42 times M5. M5 we solve. Now basically for mixing point, we have 2 unknown, M4 and M2, and 2 equation. The first equation is the mixing point mass balance, the total balance, and second one is the solid balance. So 2 unknown, 2 equation, then we can solve simultaneously. We can find M2 and M4. Settle. M2, settle. M4. We calculate it, yeah? Okay, and then we can continue with the bypass, right? Or you can continue with the evaporator also, no problem. Let's say we continue with the bypass mass balance. Why? Because this one we know, 100 kilogram. M2, just now we already solved it. So we can solve for M1, because it's simply 100 is equals to M1 plus M2. M2 we solved it already, so we solve it. We can solve for M1. Thus we have solved everything. We have M1 is equals to 90.05 kilogram. M2 is equals to 9.95 kilogram. M3 equals to 71.4 kilogram. M4 is equals to 18.65 kilogram. And M5, which is our product that we are targeted, 28.6 kilogram. So how much is the bypass fraction? How much? So that will be M2 over our feet, 100 kilogram. Our M2 is 9.95. So 9.95 over 100 is equals to 0.0995. Now we have solved the second example. Okay, so if you continue in the slides, we have several more example, several more questions, then you can try at home, try to solve it, and let's see if we can get the answer. All right, okay, that's all for today. Let's continue in the next lesson. All right, thank you very much, everyone. Goodbye.